Okay, so what we're going to do today is we are going to look at linear application word problems. So there are three that I'm going to record right now. And the first one's a little tricky. So we're definitely starting with the hardest one. So I have my little plane here because you can think of it in terms of aircraft flight, but you could also think of it in terms of a kayak or a paddleboard. So if any of you picked up any of those hobbies over the summer and you had a current, it's kind of the same thing. So we have a few vocab words here. Airspeed is the speed of an aircraft in still air. So that's assuming there's no wind. Wind speed is the speed of the wind. And then the tailwind and the headwind. This is the part that I like to have a little model for. So if you actually go on a long flight, you know how you can kind of pick a movie or something like that, they will tell you headwind, tailwind, and the pilot will talk about these winds. Maybe you never really paid attention before, but the pilot will talk about that. So the tailwind is the wind blowing in the same direction as the path of the aircraft. So the tailwind is coming at the tail of the plane, which means it's going to move it along and make the plane go faster. A headwind is the wind blowing in the direction opposite the path of the aircraft. So the headwind is heading at the head or the front of the aircraft. So by nature, if the wind's blowing at you, you're going to go slower. So always think about that when you're doing your problems, because these can be pretty tricky. So if you're with the current of a kayak, you're going to go faster. If you're against the current, you're going to go slower. Who's had that experience over the summer? Anybody in a kayak? And it's like if you're against the current and there's a good current, you're working pretty hard. So it's much easier to go with the current. All right, and then ground speed. This is the speed of the aircraft relative to the ground. So if you have a tailwind, you're going to add the wind speed. If you have a headwind, you're going to subtract the wind speed because it's going to slow you down. All right, so number one says a kayak traveled against the current 15 kilometers in 3 hours and 20 minutes. The return trip took 1 hour and 20 minutes less. Find the kayak's rate in the still water and the rate of the current. So I'm going to make a little chart here. Give yourself some space. So I did 3 long rows, and then I need some space here so that way this top left block will be blank. And I'm going to call this original trip. And then the one below, I'm going to say return trip. And then for all of these questions, we're going to go back to the notion of distance equals rate times time. Distance equals rate times time. And we'll be using that formula multiple times throughout the year. I'm just going to put D for distance. I'm going to write rate. And then I'm going to write time. Okay, so the trip is 15 kilometers. So the distance is going to be 15 kilometers here. And then if you go down and then you come back, it's going to be 15 kilometers both ways. Let me try to zoom in a little bit. Is that a little better? All right, and then the rate and the time, let's hold off on for just a second. So if you're going against the current, and that's your original piece, you're going to do 3 hours and 20 minutes. So that's going to be 3 hours, and then 20 minutes out of 60 minutes reduces to 2 out of 6, which is 1/3. So this is 3 1/3 hours. And I'm going to go ahead and write that as an improper fraction. So I'm going to take my denominator of 3. I'm going to multiply by my whole number. I'm going to do 3 times 3 plus the 1 to get 10/3. And this is going to be in hours. It's always a good idea to have your unit. Since the return trip took 1 hour and 20 minutes less, you would just be subtracting 1 from the 3 and then the 20 minutes from the 20 minutes. So it's just 2 hours. So that part isn't too bad. So also in this problem, it's saying find the chi-x rate in still water and the rate of the current. So we're looking for two different rates. So I filled in my chart with whatever I could get pretty easily from the word problem. I like using a chart because I feel like it just clarifies everything and makes it a little bit simpler. Okay, we're going to define our variables, and I don't remember if we've done any word problems yet this year. I think we did that opener right at the very beginning. And I said to you that don't worry too much because I didn't do any modeling. So now I want to model it. You have to assign your variables. It's going to be really, really important in the class. So we're going to say K equals the chi-x rate in still water. Chi-x rate in still water. And then I like to put the units. So this is going to be kilometers per hour. And then I'm going to assign C and say C is the rate of the current. Okay, and now the original trip, you were going against the current. So that's going to take, it's going to take longer. So you're going to go slower. So you're going to subtract the current, whereas the return trip went a lot faster. So you're moving together. So the current is going to be added. I will be looking, and I'm going to say that this is kilometers per hour, and I'm going to be looking for you to assign the variables. So if it's like a 5-point question, I'm going to assign a point for the variables. Okay, so you could lose a point if you didn't assign the variables. All right, and I'm going to scoot this up a bit. Okay, so now I want to write my equations. We're going to have two equations. So I'm going to start over the left, and then I'm going to work my way to the right. The first equation, we're going to use distance equals rate times time. So I'm going to have 15 equals, and then just for ease, I'm going to put the time in front just because it makes more sense to kind of put the coefficient in front of the expression. So I'm actually doing distance equals times time times rate. So that means I'm going to have 15 equals 10 over 3 times k minus c, which looks not appealing. It's kind of a yucky equation. The second one's going to look nicer. Go ahead and try to write the second equation. Okay, and using that same strategy, I put the 2 in front. So you should be getting 15 equals 2 times k plus c. This is a popular setup here where you have the plus and minus. It won't always work that way because you could be looking for distance and a rate, or the time and a rate. So it just depends on the problem. They're not always going to be looking for the rate of the kayak and the rate of the current. So it can vary. But because I have this opposite thing going on with the current, I'm going to capitalize on that. So I want to get the right-hand side to be k minus c and the other right-hand side to be k plus c. So I'm going to do that by clearing out my coefficients here. So for the first one, I want to get rid of that 10/3. So I'm going to multiply each side, and I'm going to go to a different color when I do this. By blue. So I'm going to multiply each side by 3/10. Don't let the fractions make you panic. It's not going to be a big deal. So I'm multiplying each side by 3/10. And I'm going to bring this one up here. Okay, so when I do that out, the right-hand side's pretty easy. The 3's cancel, the 10's cancel, and you're going to have k minus c on the right-hand side. The left-hand side, you have some fractions to deal with. So I always say that fractions are one of our math F words. People tend to panic on fractions, okay? Doesn't matter the level. So here I have 3 over 10 times 15 over 1. So I don't have a common factor in a numerator and denominator with the 3, but I do with the 15 and the 10. They're both divisible by 5. So I'm going to go ahead and divide them both by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. And then with fractions, I multiply across. So I'm going to get 3 times 3, which is 9 over 2. And I do want you to go ahead and write that as a fraction, no decimals. Because, I mean, this one was nice. It's a terminating decimal, but a lot of the time it won't be. And then you would have decimals that you're cutting off. So if you use the fraction, you have the exact answer. Okay, what do you think we should multiply the second equation by? I want to get rid of the 2. Any ideas? Go ahead. What is it? 1 over 2. Yep, so we're going to multiply here by 1 over 2. And that one's a lot easier. So the only one that was really tricky was that 10/3. So here the 2 and the 1/2 cancel. I would go ahead and write your left-hand side as 15 over 2. And then you're going to have K plus C. And that's all the hard work, because now the rest of the problem is going to be quite a bit easier, because now we have a system. So we reviewed systems the other day. It'll be really easy to add these together. So I'm going to add them together. The C's cancel. Okay, the right-hand side becomes 2K. And now I have 9 over 2 plus 15 over 2. So 9 over 2 plus 15 over 2 is going to become 24 over 2. Hopefully you know that that is 12. And now we really like the question because it's going to be significantly easier. So we're going to divide each side by 2. And K will equal 6 kilometers per hour. Once I've completed that, I want to go ahead and find the other rate. So I'm going to go ahead and plug this into my first simplified one over here. So I have 9 over 2 equals, it doesn't matter. I guess I could have done the second one. Maybe that would be better. Let's do the second one. So I have 15 over 2 equals 6 plus C. And then you would subtract 6 from each side. But you need a common denominator. So I'm actually going to change that to 12 over 2. They're equivalent, and then you're going to get C equals 15 minus 12 is 3, and then you keep the denominator. So that's going to be 1.5 kilometers per hour for the rate of the current. Okay, anyone have a question on number 1? These are pretty much as hard as it gets. So these are the really hard ones that we do. The next 2 examples that we'll do together are quite a bit, they're not quite as hard. Any questions? Okay, number 2. Paul is 12 years older than her brother Bob. 4 years from now, Bob will be 2/3 as old as Paula. How old are they now? All right, so the big thing with this one is assigning all of your variables. So I would write P equals Paula's age now. And then let's do capital B for Bob. Bob is Bob's age now. Setting up the problem is really important, because if you have a good setup, everything else goes better from there. Okay, and now we want to project both of those 4 years. So I'm going to do P plus 4 is Paula's age now. And then I'll do the same thing for Bob. So B plus 4 is Bob's age now. All right, and now let's see if we can write an equation from that first sentence. So when you have a word problem, it's a good idea to kind of read them multiple times. So for number 2, Paula is, so is means equal, right, in math. So P equals 12 years older than her brother Bob. Well, that's right now. So we're just going to say P equals B plus 12. You could write 12 plus B. I just put the variable first because that's kind of what we usually do. Okay, 4 years from now, Paul will be, so the Paul will be is kind of saying the equals. 2/3 as old as Paula. So we're going to say this is our 4 years from now. So B plus 4 equals 2/3 times P plus 4. Okay, and then for this one, it's kind of set up. None of these I would graph, so I showed you how to solve a system by graphing, but that's really not something that you're practically going to do. So I would use substitution here, and I would take the B plus 12 and put that in for P. So I would do B plus 4 equals 2/3, and we're going to plug in the B plus 12 in for P. So I had B plus 12 plus 4. All right, you want to combine your like terms. I would say that this is a really long question. I wouldn't say it's necessarily so hard. It's just a long question. So I have B plus 4, keeping that side the same, and then I have 2/3, and then I have B plus 16. All right, and now I'm going to use the same strategy that we used a couple minutes ago to get rid of that 3 in the denominator, and hopefully remember doing some of this in algebra. So to clear out the fractions, you can multiply by the reciprocal. So I'm going to multiply each side by 3. Now, this is 2/3 times a binomial or an expression times 3. So the 3's cancel. So then the right-hand side here is going to become 2b plus 32. And then the left-hand side will be 3b plus 12. And then I'm going to bring that up here. If you wanted to see it back a step, you would have this after you multiply through by 3. Okay, so then I have 3b plus 12 equals 2b plus 32. Go ahead and solve from here. I'm sure you can do that on your own. So I subtracted 2b and I got b plus 12 equals 32. I subtracted 12 and I got Bob is 20 years old now, and then Paula is 12 years older. So then I just added the 12 to the 20 to get 32 years old now. So Paula is 32 years old now, and I'm going to say Bob is 20 years old now, which is ironic because I'm on page 20, so that kind of threw me off for a second. All right, any questions on number 2? All right, when you're ready, let's flip over to page 21. And we'll take a look at an investment question. So this is all about money. So this is number 3, it's all about money. Okay, a total of $27,000 was invested, part of it at 10% and part at 12%. A total yield, which is the amount earned, was $2,990. How much was invested at each rate? So first thing we always want to do is assign our variable. So I'm going to go ahead and assign X and Y. And I'm going to say X is the amount invested at 10%. And then you can use a little bit of shorthand. So you remember maybe the like quotation marks mean it's the same thing the next line. By all means, feel free to use that. So Y is the amount invested at 12%. And these problems pretty much have 2 things that are tricky. First off is the setup of the 2 equations. And then second of all is dealing with the decimals. So those are the 2 things that can typically throw people off. So the first one, the first equation is always like a value equation. So you're just looking at the total amount of the investment. So that's just going to be x plus y equals 27,000. So that's just your total amount equation, x plus y equals 27,000. The second equation, and this is the one that can throw people off because you have to be really careful with your percentages. You're going to move your decimal place 2 spots. So this would be 0.10. This is going to be 0.12. If it had been something like 7.25%, then you would use, you're going to move the decimal place 2 spots. So it'd be 0.0725. Okay, so just be aware of that. You're always moving a decimal place 2 spots. And then we're going to multiply the percent by the amount invested. So this is going to be 0.1x. And we're going to multiply the 0.12 times the y, so plus 0.12y. And then that'll equal your yield. So that's your interest, so the $2,990. So it was a lot of work getting here. And then this one, you really could solve either substitution or elimination. Does anybody have a question about how I got here? All right, why don't we all do elimination? And I'm going to eliminate the x's. So I'm going to multiply this first equation by negative 0.1. Negative 0.1. Okay, so I'm going to kind of bring that down here. And I'm going to get negative 0.1x minus 0.1y. And now the decimal place is going to move 1 spot and it's going to become negative. So I'm going to get negative 2,700. And now I have this system that I can go through and solve. Okay, so I'm going to add those together. The x's will cancel, they'll add to 0. And I have 0.12y minus 0.1y. So it's like 12 minus 10. So be careful with your decimal places. You should be getting 0.02y, which is positive. So this term here is positive. So if for some reason your right-hand side turned out to be negative and you're trying to find a dollar amount for an investment, it's probably wrong. So you probably did something wrong. And then the right-hand side, when you subtract, you're going to get 290. Okay, and then you just solve from there. So we're going to divide each side by 0.02. Okay, and when you do that, you should get a nice number. So I have 290 divided by 0.02, and I'm getting $14,500. And then since the two investments together have to add up to 27,000, I'm going to subtract my answer. I don't know if you've used the answer button, but it's really, really helpful in a calculator. It's above the negative sign, so then I would just do minus answer. All scientific calculators have an answer button. You certainly can type that in, but sometimes it's just harder to do that. All right, and then I'm getting 12,500. So I just want to answer the question. So I have $12,500 invested at 10%. And then I have $14,500 invested at 12%. And that's what you need to do for that one.